Hello everyone. In continuation of solving equations, in this session, I take equations which contain logarithmic functions. Now, I do not know how many of you remember logarithmic function. So, let us start almost from scratch. Let me define first what we mean by logarithmic function. We write y equal to log x to the base a. We read it as log x to the base a if and only if x equal to a raised to y. Now, a raised to y is exponential quantity. You have already seen in the previous session. So, I need not talk about x equal to a raised to y. What were the conditions there? A was greater than 0 and answer for a raised to y was positive. That means that x is positive and hence conditions for y equal to log x to be defined, conditions are a greater than 0 and x greater than 0. Also, when you write x equal to a raised to y, we say a not equal to 1. Why do we say so? Because no one would study 1 raised to anything. That is 1. Everybody knows. So, there is nothing to study about it. So, a not equal to 1 is the additional condition. And these three conditions, that x is greater than 0 and a greater than 0, a not equal to 1, will continue with y equal to log x to the base a. Now, when I say that a greater than 0 and a not equal to 1, does that tell you something extra? That means the moment you are saying a not equal to 1, you have broken the number line 0 to 1 and 1 onwards. And hence, we will pay attention to a all the time. It is either between 0 and 1 or it is more than 1. A is called the base, as I said before. Now, I try to draw graph so that clarity would be there. I would draw x-axis, y-axis, normal, like how we draw. And graph for y equal to log s to the base a for a less than 1 but greater than 0 would be something like this. And similarly, we would draw graph for y equal to log x to the base a, and that would look like something like this, which is for a greater than 1. Now, again, when we see two graphs, there are certain things which you can compare between those two. And we see that for a less than 1, that means the first graph, the left one, log x to the base a decreases as x increases, but on the right, we find other way. As x increases, even y increases, means log x to the base a increases. Also, both the graphs are on the right side of y-axis. That tells that log x to the base a is defined only for positive values of x. When I say positive, not even 0 I am saying. Graph does not meet even the y-axis. Also, what we observe is log x is greater than 0 for a less than 1 only for the values of x which are between 0 and 1. And log x is less than 0 for a greater than 1 for the only values which are between 0 and 1. I mean, these observations you can make. And one more set is remaining. And that is log x is less than 0 when base is less than 1, that is a less than 1, and x greater than 1. And similar thing you can say about a greater than 1 also. That log x is positive for x greater than 1. These are the observations which you may require. Not immediately for this session, maybe somewhere else also in other chapters. Now, there are certain properties of log which you must remember. So, we will take them one by one. Log of mn is log m plus log n. And mind you, please, same base I have written everywhere, a. Log of m by n is log m minus log n. Again, base is same, a everywhere. Log m to the base n is log m upon log n. And mind you, please, I have not written there any base. Base you can choose of your choice, and that is why this property is called change of base property. Only thing what you need to remember is that when you are choosing base, it should satisfy conditions of base. Means it cannot be 1 and it has to be positive. Now, log a to the base a is 1, and also log x to the base a can be written in terms of log a to the base x. This property is also important in problem solving. And then the last one, a raised to log x to the base a is x. Now, we have done something in function, and there we have done inverse of a function. Exponential function and logarithmic functions, they are inverses of each other. So, what happens that a raised to what you are saying, that would be finished when you take log, or other way. If you have taken first log and then you make a raised to, then again their effect is lost. So what happens? You arrive at same thing with which you started. So x, then you take log, and then you make a raised to. That is your left hand side. And right hand side is nothing but x. Because log and a raised to x, I mean the exponential function, they finish each other. Now with this background, let us take some question. Solve log of x square minus 6x plus 7 equal to log of x minus 3. Mind you please, I have not written there any base. Now, what could be base? Anything which is not 1 but positive. That base you can choose if you wish. But frankly, in problem solving, you may not need that base right now. Now, I start as log of x square minus 6x plus 7 equal to log of x minus 3. You are seeing log and inside some quantity is written. Log can be taken only of a positive quantity, and hence I will have to check what is the feasible region. So I go for feasible region and I put conditions on x square minus 6x plus 7 and x minus 3. Both of them will have to be positive, then only you can take log. And I simplified further that x square minus 6x plus 7 greater than 0. This simplification is exactly of what you have done in your basic algebra. That leads to x minus 3 whole square greater than 2, and x minus 3 positive tells me x greater than 3. Then simplify that x minus 3 whole square greater than 2. Use your basic algebra knowledge and finally get your feasible region as 3 plus root 2 to infinity. Now when I am ready with my feasible region, then only I will proceed for further solving part. Now since log, if you check the shape of the curve, is injective function. When I say injective function, recall fx1 equal to fx2 leads to x1 equal to x2. Log function is injective function and hence I can write x square minus 6x plus 7 equal to x minus 3. Solve normal quadratic equation. How you solve? Bringing all the terms on same side. X square minus 7x plus 10 equal to 0, and that would lead to x equal to 5 and 2. Now what you have to do? You have to check which of them is in the feasible region. And I realize that x equal to 2 is less than 3 plus root 2. So it doesn't lie in the feasible region. So the only option for us is x equal to 5. And that is the solution of the equation. Now, don't you think we should take one more, right? So let us move further and take another example. The number of solutions of the equation x raised to log of x plus 7 whole square to the base x equal to 64 is, and then 4 options are given and we have to pick up the right one. Now, when you read the question, you may feel that it is difficult, but do it stepwise. As I keep saying, first thing is you have to work on feasible region. Now, since base is x there, so x cannot be 1 and x has to be positive. Also, x raised to something you are saying. So that base means x again. Even that needs to be positive. So that we have already covered. So x not equal to 1, x greater than 0. This would be the region where we would work. Also, just now we have seen a raised to log x to the base a is x, and equation's left hand side is actually in that form. So I can rewrite that equation as x plus 7 whole square equal to 64. And that would lead to x plus 7 equal to plus minus 8. Simple. And then that gives me x equal to 1 and minus 15. Now check which of them is in the feasible region. X equal to 1 discarded because x not equal to 1. Equation 1 tells me. And also we are saying x should be positive. So x equal to minus 15 is also ruled out. So there is no solution to the equation. So number of solutions, 0. So my correct option is D. Now this particular session we had only equations containing logarithmic functions. In the previous session we had equations containing exponential functions. I have not taken inequations containing logarithmic functions or exponential functions. Those who are interested can apply exact information what is given here in those observations to the inequations and they can try themselves. Now again, when I come next session, I will again come with something new. Till then, stay tuned. Thank you.